Now that we understand the basic concepts of using variables within Unity, let's take a look at some of the variable types that are available to us. The first variable data type we're going to take a look at is an integer. We declare an integer using the int keyword, or int. You'll remember the specific format for declaring a variable is the data type first, followed by the variable name. You can either then end the statement with a semicolon, or use an equal sign to assign some value to your variable. The integer data type can hold whole numbers, things like 1, 2, or 50. It can't hold decimal places, and so it's very useful for doing things like discarding the remainders of a division. The next data type we're going to look at is a float, which is short for floating point number. To create a float, we start with the float keyword, followed by the variable name. Floats can store any numbers, even if they have decimal places or remainders. For instance, a float can store 5.5, 6.2, 3.14, or any other number you can think of. An important part of using floats within Unity is that after typing the number or the value that you want your float to have, you need to follow with the F character. This character is important because it denotes that you intend for this value to be stored in a float as opposed to any other possible numeric. This is useful because while floats might not be as precise as some other larger data types, floats are incredibly efficient and fast to use. And when working with video games, fast, efficient variables are very useful. Most of the numbers that you're going to use within Unity will be floats. The next data type is called a Boolean, or bool for short. A bool can only have one of two values, true or false. It can't store characters or numbers or anything else. Bools will always either equal true or false, and by default, if you do not give a bool a value, the value will be false. You assign the value true or false by using the words true or false. Bools are often useful for storing the results of some decision-making process, or the state of some object in code. For instance, you may want to know if a character is alive. You could declare a Boolean variable named isAlive, and while that variable equaled true, we knew the player was alive. If we need to store text, something we call string literals, we're going to store those in a variable type named string. The value of these string literals, or string for short, is often text which is required to be written with quotation marks. The values of strings can have spaces, special characters, whatever you want, as long as they're in between two quotes. We can also perform simple functionality on these strings to do interesting things. For instance, if we were to declare three strings of name mystring, mystring2, and mystring3, and give them the values of hello, space, and world respectively, we could then add them together using a simple plus sign and store the result in an additional string variable. The resultant string, in this case we'll name that result, will equal hello space world. These four variable types, integers, floats, booleans, and strings, are the four most common basic data types you'll use inside Unity. However, there are a lot of more complex data types that we use a lot as well. One such example is the vector3 data type, which is really a data type that simply stores three other float values. Giving vector3s a value, since they are complex, is a little bit different than giving a value to, say, an integer or a boolean. We're still going to use the equal sign, however we can't just specify some value because vector3s store three values. Instead, we use something called a constructor to construct a more complex vector3 out of base types. We do this using the words new, followed by the data type vector3 and the values we want. Now, we have a vector3 variable named myVector, which is set equal to 4 on the x-axis, 5 on the y-axis, and 10 on the z-axis. Additionally, we can access the smaller pieces of this vector3 individually to make any changes that we would like. We can say set the x value of myVector to 10 instead of 4 as it was declared. We could even say take the y value of myVector and add the myInt that we had before. We could also say take the y value of myVector and add to it the myFloat variable that we declared above. The plus equals operator that you see on line 20 is a shorthand operation. Effectively, what it means is take the y value of my vector and add to it the value of my float. Written out long ways, it would look something like this. Since we generally don't want to do all that typing, again, it can just be shorthanded or shortened to look more like this. Vector 3s are used a lot within Unity, as they store things like positions, scales, Euler angles, color data, or any other time where we need to have three float values that are linked together. Another data type that we use a lot is one created inside Unity that we can get references to keep track of players and objects within our scenes. That data type is the transform. You've seen before where we've manipulated a transform using the lowercase t transform. What that is the transform component on this specific object. If we use the uppercase t transform, that's a data type where we're saying, give me a variable of this type, transform. Using this syntax, we can store or cache a local reference to a transform component. We can then manipulate this transform as if we could any transform component. There are many more built-in data types in Unity, too many to go over in this video. It's worth noting that every component type and every class declared within Unity is in fact a data type. You can even create your own data types. Anytime you create a class, you are effectively creating a data type. For instance, here we have a class that we've been using all along called SampleScript. Because SampleScript is a class, it is therefore also a data type that we can make variables of. This is very useful for storing references of one class object inside another class object to be used. For the sake of the example, we can also declare variables of the types of the other scripts we've made in this section. For instance, our translate and rotate script, which we used in a previous section. All in all, there are many variable data types that we have access to both through C#, UnityScript, or Unity itself. There are too many to list, and the documentation on them is quite extensive. It's worth noting, however, that they all generally have the same format: data type, variable name, and value. Knowing that, you can manipulate all of the different types of variables with very little difficulty.